Okay, so thank you for joining the call. What we have here is that we have a recorded webinar, and it's with one of our partners that has been with Oracle for a long time, working more in the crystal ball space, but now has become an Oracle Primavera partner. And it's a man by the name of Eric Torquia, and he works with a company called Technology Partners Incorporated. He is based out of Montreal, Quebec, and I've actually had the privilege to meet him multiple times, and he lives there, specializes in analytics and risk, and has been working within the realm of enterprise software for approximately a dozen years. He has an expertise in the risk space, and I wanted to get him on the phone just to give an overview of how Oracle Primavera risk analysis can help our clients possibly use the software and the concepts behind risk to more effectively manage their projects. So Eric, I don't know if you want to take over here. You have everything presented, and you can just go right ahead. So go ahead.
Thank you very much, Matt, for a kind introduction. I've also had the pleasure of meeting Matt a few times, and it was always most pleasant and informative. We're going to get started, and we're going to fire up our presentation over here. So today we're going to talk about reducing project costs and risks with Oracle Primavera Risk Analysis. Maybe to get started, we're going to talk about what we do. Essentially, Technology Partners Limited supports its clients in improving its decision and business outcomes by working on making decisions, enterprise project management, and enterprise performance management by providing the following services: model building, time series forecasting, simulation, and optimization. These are the technical things that we bring to the table. However, we understand that analytics is a lot more than just software and people that are, very sophisticated with the math. It's also an enterprise problem. And a lot of what we do focuses on strategy, business analysis, so figuring out what the problem is or designing one, identifying the right solutions, and change management to make sure that the people actually work with this. If you'll bear with me, I'll just take a quick second and explain this little washing machine thing over here. This is the Dynamic Enterprise Alignment Model, which we published about 5 years ago in the Encyclopedia for E-Collaboration. And basically, it means that every organization has target business objectives. And whether it's an individual, a department, a division, or an entire firm, they have objectives, and they only have 3 levers to achieve them: people, technology, and operations. So people are the ones doing it, technology are the tools that they're doing it with, and operations is how they do it. And these 2 snakes over here talk about how you would continuously improve by, teaching your people new things, getting new technology, changing your processes. But it's also done in the context of it being necessary in the market, which is alignment. So what we do is that we help people pick the right solutions, figure out how they're going to work for their business, and make sure that they learn how to use them to get the most out of them. Some of our clients include some very big names, such as Schlumberger, Monsanto, the United States Geological Survey, Xstrata. So you'll see that there's a very broad range of clients, ranging from manufacturing to services, to extractive, finance, and retail. Some of the tools and the people that we work with beyond Primavera are Oracle Crystal Ball. We work with AutoView and a host of other analytical solutions that are specialized in the risk realm. This handsome young man is myself. Quick description of who I am. I've been working in the realm of risk analysis for about 6 years, enterprise software for 12. Some of the projects include risk analysis on mega projects, feasibility, financial valuations, portfolio work. We've done business analysis to design systems and ERP projects, organizational change, and we also have a lot of technical expertise with Excel and a host of add-ins, as well as project risk analysis by Primavera. So let's get into the meat of the presentation. So let's see how risk analysis can translate into immediate ROI. So how do we get dollars by using Primavera risk analysis? So we're going to talk about the difference between working with averages versus ranges. We're going to talk about what are some of the challenges and opportunities that are embedded in simulation and risk analysis, because PRA, for Primavera risk analysis, we'll refer to it as PRA, is a simulation tool. And we're going to see how we can make better decisions with richer information. So the first thing is, let's talk about averages. A lot of people like to talk with averages, all on average this, on average that. Let's see how that plays out. Here we have a river, and we have to cross this river. And what it tells us is that there is an average of 3 feet to get across. So theoretically, we shouldn't get, more wet than around the waist. However, this is an average. So the guy that has to cross this, he's not a very good swimmer, so he's very dependent on this piece of information. So as he's crossing, he's realizing that he only has about 6 inches of water covering his shoes, and then he slips and he drowns. And the reason is that you got 6 inches of water across, but you have a precipice here of like 18 feet. And he doesn't know how to swim, so he drowned, and that made it for a very bad day for him. So that's the message. Averages conceal risk. And working with PRA and risk analysis, we actually look to find out what those concealed risks are. So, whoops. So let's take a typical example of how this plays out. When you're doing an analysis, here we have a business opportunity that we're trying to analyze. And we see that we have a worst case, a best case, and a most likely. And in each of these, we've made assumptions, how much volume, the price, and the variable cost. So our case analysis is over here. It's a very simple calculation. Your volume times your price minus your volume times your variable cost, and this gives you your profit scenarios. And we can see that our first case would make $55,000, or most likely $142,500, and here's $180,000. But what does that mean? So let's see how this works. So the old way is that we would take these and we would look at them. So there's only 3 possible outcomes. You have a pretty limited view of risk. You don't know what's making this number go up or down. You don't know what are the odds that you'll miss your number. And you don't know what number you should give to your boss. So you have 3 possibilities, no probability. By working with risk analysis tools, what you're getting is the new way, so quantifying risk and uncertainty. And what we have here is a distribution that takes the exact same model, and this is what happens. We get a full range of outcomes, so we have the full distribution. We know that there's a 60% chance of being below profit expectations. So if we're looking over here, we know that our profit was 142, and based on our most likely, and there's a 60% chance that it will be less than that. 10% chance that you're going to be below your worst case. So you thought it was going to be 55, but actually it could be up to minus 50. You have a 20% chance of doing better than that. And if you run your sensitivity analysis, you know that price is the biggest driver on your profit. So what you have is all the possibilities and clear probability. And that's what risk analysis does. So if we took this a step further, and we had the same thing, but now we're looking at two cases. So the first case we already looked at, 142.5 being our most likely, and then the second one, we're looking at another product. And it says that this one has a worst case of 10,000, a most likely of 116, but could have a best case of 384. So, the question we ask, and I guess, Matt, I'm going to have to ask you here, what are your thoughts? If you had to pick a project, and I came to you and I said, look, I got this project at 142.5, and another one here at 116, which one would you pick for their NPV?
You know what? It was a tough decision. I'm going to have to go with the 142.5 based on that information.
All right, excellent. And I'm pretty sure that a lot of people would agree with you. So I'm going to give you a little more information. Now, if I told you that this 142.5 had a possibility of being minus 20 and up to 345, and the other one being 47 and up to 335, a maximum, which one would you pick?
Based on that information, I might go with the 116 number.
All right. So now you have a little more information. Now let's confirm this. So if we look at this, you were absolutely right, because not only that, but if you said that you had a business objective, and we picked 150 here, that you had to make 150 was your hurdle rate, you would have a higher probability of making that number with 116 with the second project than you would with the first one. And that would never be known unless you ran this kind of analysis. So that's really what risk analysis does. So what's the definition of a range? Well, a range can define a series of potential occurrences, and they're necessary to communicate more useful information. I'll give you an example. Most people, when you confront them and you ask them for an estimate, how long is it going to take you to build this wall? How much time does it take to do this? And so on. Typically, their first reaction will be to answer you with a range. And they'll say, well, gee, I don't know. Maybe it'll be 2 weeks or 3 weeks. So the conversation tends to unfold the following way. They go, okay, well, which is it, 2 weeks or 3 weeks? I don't know. Well, let's split the apple in two and say you'll get 2.5 weeks. Or in a lot of other cases, the person will be told you get 2 weeks. So up till now, you're getting range information. And if someone said, well, it's between 2 and 4 weeks, but I think it's going to be more around 3.5, you know that naturally this guy is feeling more pessimistic about how it's going to unfold. So you have an understanding of the bias of the guy providing the estimate. So that's why ranges are kind of cool. And they give you a lot more information to work with using the same question, how long. You can use it with historical data. So if you had a lot of projects that were similar, you could figure out how much it was. Some people use estimation tables. They can be known statistical distributions, rules of thumbs. And just like we talked about, you could use 3-point estimates. So if nothing else, you can talk to a subject matter expert and get a min-max or a min-max and most likely. So simulation models require ranges as inputs. That's the key takeaway. Now, how do analytics improve project process performance? We're going to talk about why more than 50% of projects fail to meet expectations. Why are they failing to meet expectations? What is the cost to the business? Is there anything we can do to improve our batting ratio? And are there other barrier crashing opportunities? So let's take a look at this. So more than 50% of projects fail to meet expectations. An interesting quote, which has been around for 40 years almost, basically states that initial cost and schedule estimates for major projects have invariably been over-optimistic. The risk that cost and schedule constraints will not be met and cannot be determined if cost and schedule estimates are given in terms of single points rather than distributions. So this was from a report from the U.S. Air Force in 1971. So what we're talking about is nothing new. It is recognized by the PMI, and it is best practice. Now let's look at some numbers. The Chaos report produced by the Standish Group takes a survey every couple of years on project success rates in the field of information technology, which is notorious for having high failure rates. In the early days, back in the early 90s, you saw that you had let's define the terms first. Success means that the project met expectations, cost, budget, and spec. Failure means that the project got canned along the way. Challenge means that it got completed, but that something went wrong. It cost too much, took too long, or it was underdelivered. So coming back to that, in the early 90s, we saw that 30% of projects, up to between 30 and 40% of projects got canned outright because they failed. Whereas the success rate was somewhere between in the 30s, but the challenge rate has always remained in the high 40s and 50s. And no matter what we've done, we've always been able to kind of address the absolute failure rates, but we haven't been able to really deal with how many projects are challenged. So we have a barrier there, and we need to break it. So simulation and optimization will improve project success. So why are so many projects challenged? Well, most project managers and organizations don't really look into the risk from a quantitative point of view. So some tasks can appear critical when in fact they aren't. If you just rejig your schedule, a task can become uncritical. And if that happens most of the time, then you might be making bad decisions with bad information. Setting credibility, there are credibility issues that are associated with setting the right funding and budget levels. So if you go to your boss and you ask him for too little, and then you have to go back to the well, you'll see that that's not going to go over too well. And of course, the other thing is, and that's a risk unto itself, by the way. And the other thing is, you want to understand what are the tasks and the costs that are really affecting your delivery dates. And if you know these, then when you're building your risk plan, you can actually start making conscious decisions on how to address these things. So you can plan and you can deal with your budget and your scheduling risk by using simulation. So what are the costs of challenged projects? Well, you have a bunch of rework. And when you have rework, well, the project slows down, which means you're keeping more people on the payroll that you have to pay, and more meetings and more admin. Scope creep becomes very difficult because once you've slowed down the project, everything gets put back into question. Then they try to add features, change things, and that becomes a mess. Your project, because of these things, you tend to have a higher risk of your project failing anyways. It's cost you more, so you're not making as much money. And at the end of the day, the people that are responsible for this fiasco look like fools. And getting credibility in the organization becomes hard, and selling future projects, and again, very difficult. So you have a lot of things at play, and if you try to address these, you could probably get through that 50% barrier. So essentially, most organizations work in the following way. They build an operational plan, it becomes tactical, and then there's a strategy. So in our world, that means that there's an estimation process. Estimation, and I would add identification of projects. So cost assessments, time to replacements, failure modes, system improvements, process improvements, etc. Then we go on and we look at project plans. So what would it cost? How many people do we need to throw at this? How long does it take? Do we have the right people to do it? And when we've done this analysis, then we figure out the long-term, financial viability of all of this using consolidated financials, NPV, go, no go. And then if you have a bunch of these projects that have been done from a capital perspective, they go into your portfolio plan. So once they're in your portfolio plan, and this can be done very elegantly with Primavera Enterprise Portfolio Management, then you can look at execution scenarios, your resource allocations, and then you can either optimize using the search algorithm, the filtering algorithm rather, in Primavera, or you can export this to another Oracle, into Excel, and use another Oracle tool called Crystal Ball and do an optimization of your portfolio plan there. Anyways, at the end of the day, management decides what they want to do. And when they've done that, then this comes back to the middle management, which has to figure out how they're going to get this done, and then the operational people that put rubber to the pavement. Some of the other things that you can look at by using project risk PRA is project feasibility studies, project selection if you have a couple of them, bid analysis, scheduling, resource planning, risk identification, critical path optimization. Then, of course, if you're working with in conjunction with tools like Crystal Ball, you can also do benefits and valuations, asset management strategies, financing, and so on. So what you need to look at is that these are all, if you hear these key words, these are all things that PRA can support an organization in achieving. And there are more. So let's get into the slightly technical aspect, and then we're going to be able to look at some case examples using PRA. So in this piece, we're going to do a very quick, very summary introduction of what is Monte Carlo simulation, because this is what PRA does. How does it fit into the project and the business? And how can you enhance the process of planning and managing projects using simulation and optimization? And then, like we said, we'll take a look at some cases. So the first thing is we'll just take a quick look here. And we can replace, this is a generic diagram that we developed a while ago, and it explains how analytics fits into the business. It kind of follows up on the little process we looked at earlier. You have people that do the work, knowledge workers, project teams. You have analysts, and then you have management that makes decisions. They generate data, they analyze the opportunity, and submit it to management, who decides if they want to do it or not, and then they throw it back at the middle management part, get it done, figure it out, and then these guys do it. And that's the loop of analytics. So that's how it fits into the business in a general sense. What do simulation analytics do? So why are we doing this? So we use PRA because we want to quantify the effects of variation in our current as-is scenario. So we want to figure out if we apply uncertainty, what does it do? Then if we need to make some targets, delivery dates or costs and so on, we want to figure out what are the odds of us making those targets based on the uncertainty we have. Then, as we talked about earlier, we want to figure out what are the variables that are making that plan go up, and which tasks, which resources. And then when we've done that a number of times, we can figure out what's the best way to strategize our project so we can deliver on time and on budget. So this is what it looks like. So we have a bunch of tasks, and they have different distributions, and we have a project team. So I guess maybe we should start from the first. We get a project plan, and that project plan can come from a bunch of systems. But of course, we would like to say that they all come from P6, but some of them will come from Project and Deltec and some other. So the solution is very flexible. And if you're working with data that comes from a lot of partners using different project management tools, this really helps. Then we throw all this stuff into a PRA, and then we apply these distributions, we run it, and then we look at costs and delivery dates, so this little histogram over here. We can look at what are the drivers, and then we can look at S-curves. So this is generally how it works. Would you add anything else, Matt?
No.
Still there?
Still here for sure. No, I wouldn't add anything else. I mean, you're doing a great job covering it.
Oh, that's very kind. Just wanted to make sure I didn't forget anything. So, but now the other aspect is how do you actually do this? So typically in a business, when they're defining a project, they have to set objectives. And they go out to the business, they talk to the people, set those objectives, and they have a plan, and they figure out where they're going to get their historical, their assumptions. They go off and they build a plan in MS Project or in P6. Then based on that, they'll have a model, and hopefully they'll go and they'll validate those assumptions with the subject matter experts that they consulted in the first place. And then they're going to take this and they're going to project it over time using a Gantt chart or do some what-if analysis. And that's usually where it ends. And what we tend to bring to the table using PRA and P6 is that we bring a whole layer of risk analysis. And that layer still means we're going to do all the other stuff that we did before to build our project plan, but this time we're going to ask them for range information and specific targets and forecasts that they want to achieve. And then we're going to document that with the business rules and what are the things that need to happen first. Then we run it. We look if it makes sense. Are we comfortable with the risk profile? And we figure out what's really driving the model. Is it volatile? Is it valid? So we go back and we say, hey, guys, this is when we've run our model, our strategy for the project, this is what it gives. Are you okay with that? Yeah. Then we need to maybe optimize. Hey, that might take too long. Can we do a project crash? Or can we accelerate the delivery of so-and-so deliverable? Can we mitigate the cost by transferring it, contract, so on? So that's when we work on the planning. And then we look at maybe other scenarios. And once we've done that, we can run it again, build out our scenarios, export it to Excel if you want for special reporting purposes, and you can share that with the business. And that's really where they're going to have a lot more information to make informed decisions about what they should be doing. So now we're going to get into the nitty-gritty of it. So the first part we're going to look at is how to add variance into your project. So to do that, we're going to try. This comes to the planning piece, and what we're going to try to address are the following management questions. Does my scheduling plan work? First thing, has it been done to best practice? How long will this project take? What are the things I should be planning for? What are the real critical tasks? So these are the things management really is pondering. So let's take a look at what that looks like. The first thing we're going to do, and I'm just going to move this so I have my notes up, and here we go. Okay. So the first case. So the first thing we're going to do is we're going to import. I'm going to show you how easy it is to import a project from any system. Now, if we were working with Primavera and we had a saved file, we could do that, or we can link in to the database if my memory serves. Today, what we're going to be working with is an MS project file, and that will be just as easy to open. So we're going to open a file, and here we go. We have this. And what you'll see is that it asked me for the wrong file. Okay, great. Let's see. In this project, we'll just make sure that we were in the right directory. Yes, we are. And for some strange reason, I saved it in version 2010 by accident. So we're going to probably forego this step. But in any case, it will open it and import it. And for this, for the purposes of our discussion, it'll import it and it will give you the following. Okay, here we go. So we have this. There we go. Excellent. So it imports it as is. And what we already did over here, and we can do it again, is that we're going to do a quick check. And to do that is we have this check, and we're going to see if this project was designed right. So it runs a check on all the tasks, and it produces the following report. We can pull this up. And we can see there's a plan summary, how many tasks are in project. Now, we can see that this is still a project that hasn't been started. So if it had been in progress, we would have had different numbers. And then it does an analysis of all the things that could probably cause you issues if you were simulating or looking at it. So open-ended tasks, leads, lags, and it gives you a full analysis of the distributions. And in this case, we use triangular. It picked up all the stuff we did earlier with their values. So this is a very useful feature, and it's the first thing you should probably look at when you're doing importing a schedule. Now, what we'll do is we're going to add some risk. And what we figured out is over here, the analysis part has its own little. So we're going to overwrite. We're going to take these selected tasks, and we say that there's 90% chance. That the minimum is that 90% of whatever we figured it was going to be and then 150. So if we had a most likely of 10 days, so we'd figure 9 days to 15 days with a most likely of 10. So in this case, we figured this is a much riskier aspect, and we're going to do it at 200, or actually even better, 225. And we're going to hit OK. And what we have done, if we were looking over here, is we have changed the distributions and the inputs to reflect that. So, and we could do this for the whole schedule. You can filter, and in fact, if you want, there are many. The way you would do that is that you can view different filters. So here we're going to go over here, filter, and we created 2 filters for this. So what we want to see are what are the simulated tasks. And we can see that all the tasks in the schedule have been simulated. Now we're going to run this. We're going to clear our filter. Okay. And we're just going to close, and I'm just thinking, there we go, clear the filter. And we're going to run it. So to run this, all you have to do is press this little dice thing. And here we can run 10,000 trials, and there's some options. It'll calculate cost sensitivity, duration, save the NPV, how many trials, and then you even have Latin hypercube. So if you have a really, really big project, you can use this to save time. For our intents and purposes, we'll be doing Monte Carlo. So you have a bunch of really interesting and very powerful features here. And now we're going to analyze. And then they have a very interesting, so we could step through. So if we were stepping through, and that's what we're going to do, we're going to cancel this so we can look at the Gantt chart together and see how risk analysis does its work. So now that we have the schedule, we'll see what we'd be doing 10,000 times. We come over here, analyze, and let's step. So different tasks have done. So this would be one scenario, and the project would finish in June of 2012. And what we can see is it finished in September at one point. So we're going to do this, and we're going to say complete, and we're going to tell it that we want it to run 10,000 times. But because we told it that once it converges on a specific answer, it can stop running, it might stop running much earlier than that, still giving us the precision that we needed. So we're just going to let this sucker go. And while it's doing that, I'll explain what it's doing. Essentially, it is taking the schedule with all its relationships, start, finish, constraints, resources, and it is putting it into a program in the back, and it is running it. And what we can see is that it is running, and I think it actually is going to go through the 10,000. It's running it, and it's trying all these scenarios. And I think maybe this will probably be a little, okay, that would probably be a little low, a little high rather, just for the purposes of our discussion. So while we do that, let's talk about some of the things that you can set for each one of these tasks. By the way, you can see how the schedule is getting updated and it moves. So you can deal with dates, constraints, links, resources, costs, uncertainty, and then you can have you can even suspend and resume tasks. So you can create conditional branches. So what happens if it rains? Will the crew be working on the roof or will they be working on the foundation, to use a crude example? So there are a lot of things that you can do with that. And see, now we're calculating all the percentiles. Sorry, I don't want to sound, okay. This is what we call the distribution graph. And we have those for, what's very powerful about PRA is that it calculates this for every task in your schedule. It does, so you don't have to specifically go into it. And tasks which have been simulated and are deemed uncritical are green, and the ones that are not are red. So let's analyze what these graphs mean. So determining project scope, let's pick a rich one here. So what we have here are all the possibilities that have been simulated over 1,000 times, and here it says about 300 of the project plans ended up at this date, and another 365 over here, and so on. So if we wanted to be 90% sure, so meaning that 9 times out of 10, you'll finish this task on this day or before, you would have to figure that you would have to plan on the 23rd of January. And the base case, the deterministic, said that you would be doing it on the 18th. So there's only 3 chances out of 10 you would actually make that date. And if you wanted to be 90% sure, so 9 times, you would have to add about almost a week. If we take another task, maybe it has more bars over here, what we have over here is how to incorporate the feedback into the functional specifications. And over here, we have our deterministic, so we have a 6% chance, this is the black bar, and then a 50% chance that it would happen on the 21st, and then a 90% chance. But this is not the only view that we can have of this task. We can look at the start date, and we can see that the start date is a distribution all to its own as well. And that too would need to be accounted for. But there's also duration. How long is this task going to take? So this wasn't a very long task, so this is 1 or 2 days. We can look at how much float there is. What is this cost? We didn't have a lot of cost data in here. And yes. And then and then what we're going to look at NPV data. It didn't calculate it in this one because we didn't supply it, but we have another example where we'll be looking at this. So that's this example covering how you would apply variance very quickly to a schedule. So I guess since we're recording, I was wondering, Matt, if you had any questions or if you'd want me to go through any of these items again.
Yeah, the only thing I would say is can you just, I mean, obviously it's a Gantt chart, but can you just configure that just so that it's, closer up so you don't see all the way out to 2013? Is that a possibility?
Sure. I was worried it was going to be, I was worried you were going to ask me something more complicated than that.
I wouldn't do that to you.
All right. So does that look better?
Yeah, I just think it gives, when you're looking at this, it just gives them more, you can see what's happening as they're running the simulations a little bit better as things get moved in and out.
All right, so we'll make sure to look at that on the other two examples. So this covers this one. Okay, no. So our next example, just switch back our. So the next example comes in over here. Okay, so now what we're going to do is we're going to talk about estimating costs and budgets, but by really taking into account this risk information. So why do we do that? Well, we really want to figure out how much we should budget for contingency. Which work package or activity plan is the riskiest, and how will this impact the planning? So, whoops, just move back to that. So this is what we're going to try and figure out. And to do that, we are going to pull up another example. Close this guy. Okay, we're going to go with pre. Pre. Pull up my notes. Okay, so first thing we're going to talk about is the risk registry. Okay, so I guess I'll just pull it up from the example file. So open samples, and then here we go. Okay, so what we have over here is the risk register. And the risk register provides two types of risk, qualitative and quantitative. So the quantitative, we kind of showed you how we did that. We went out, we picked our distributions, we applied, we picked our tasks, we applied our distributions. Over here, and here it picks it up, tells you what tasks have they been quantified, so on. Then there are qualitative risks. Do you have, for example, contract delays, delivery overruns, your fabricator goes bust. So all of these things are things that your SMEs are going out and telling you could happen. And using the very traditional method of weighting, and you can pick if you want to have, a 5-color scale or a 3-color scale, it will allow you to create a complete risk registry. And you can define some of your own fields. You will define how you're mitigating it and who's dealing with it. You even have a waterfall chart that explains how it deals with the risk. And then you have the history, so all the things you've done. So just as a documentation tool, forgetting all the other stuff, you have a very complete toolkit for documenting these things. What the beauty is about PRA is that it will enable you to tie those qualitative risks with impact back to your quantitative plan. So we can go here in the probabilities, which we can set the weightings for each one, very high, negligible, 10, 30, 40, 50%. And it will change the score, and it will color code it automatically based on your risk matrix that you define elsewhere. then how do we assign these? So the pre-mitigated and post-mitigated. So what these two views say is that we can quantify these, and then after we did it, what did it cost us to actually deal with them? And this enables us to create two scenarios, which is what I was trying to load to get at this risk registry. Enables you to compare how your risk profile changes by doing these things versus not doing them. So I think that I'll just close this because I think this makes the point of how the risk registries. Well, before we do that, I'll just show you one last thing. So if we went over here, we can look at a task and we can say A70, right? And then we can tell it where it is assigned. Sorry, on the pre-mitigated. So we can say, okay, on rework initial design, this has now added this task. So you can assign tasks to specific risks with a probability of it happening, and then what happens, and then the impacts are defined over here. Okay, moving on. So then, now what we have is the pre-mitigated. So this is the same worksheet that we were looking at. However, we have not added any risk methods. So we're going to run this guy for 1,000 times. And after that, we'll be able to look at certain things. So in this case, just to take a quick look, we see that we have a 100% probability that it'll cost up to 33 million. Our 90 is at 28. Our 50% is at 26. But check this out. Our deterministic cost is 14%. So if you went with your risk plan to your superiors, you would have basically an 86 chances out of 100, you would end up costing more than what you thought. And that's on the cost. And the finish date. Over here, same thing. There is less than a 1% chance that you would be able to deliver on the date that you said, and that it would probably take you almost 8, 9 months longer than you had anticipated to be at 80. And probably at 90, it's 10 months. So that makes a huge difference in your planning cycle. And imagine all the problems it can cost a company for not delivering. A prime example is RIM that's been having a bunch of project delivery issues when it comes to products. And strategically, they couldn't handle it. And imagine if they had been applying these methods, to figure out their risk. They probably would have had a much easier time at it. Anyways, I digress. So the next step is that we're going to compare this, okay, by pulling up, so we're going to take this guy, and this is the pre, and and the post. So actually, we already had it done. So we loaded the pre and the post mitigated plans. And what you'll notice is on your finish date, your 100% on your risk mitigated plan over here is happening in June, whereas over here it's sometime in October. So you've basically reduced your upper bound by 5 months, which could be huge, especially in terms of cost. Your 80% has a 161-day difference between the delivery date here, which I should have picked a better percentile, but we have it over here, and then the 50%, and you'll notice that both starting off relatively at the same place. Start date, nothing to worry about. Duration, same thing. This is in terms of days. You're up to about 1,000 here. Over here, you're at 1,500. Cost. Look at that. Your post-mitigated plan could probably cost you a little quicker, faster, but it tops out at a lower cost. So having done this, even if everything went wrong, you'd still save $3.5 million or 10%. And probably you do a little better than that at any point in the project. Last but not least, well, the internal rate of return didn't work, and then you can get a consolidated view of all your numbers. And then, okay, another thing that we might want to look at, so that's pre-mitigated and post-mitigated. Do you have any questions or things that I should go over again, Matt?
Yeah, I think it's a good overview of how that's, you can apply percentages to tasks and whatnot.
Excellent. You can also set up most of the colors in here, okay, because some people might have different color schemes for their projects. And you can set up indicators over here that give you a bit of a dashboard feel about what you should be looking at. And you can set these up for duration, cost, and so on. So then there's the probabilistic cash flow. So I'm just going to bring up my next slide over here. All right, and this we're gonna present. I'm going to talk a bit about Crystal Ball, but really we're going to look at how PRA does it for a strict cash flow on your schedule. And of course, you have to input some information into your project to be able to. So the more you put into your plan, the richer the analysis you'll get out of PRA. So some of the questions management might be wondering about is, what is the impact of my project budget on internal rate of return? How likely is it that I'll make my 15% hurdle rate? What are the biggest drivers I should be planning for? How will my NPV look like over time? So some of these questions are answered by PRA, and some of them are a little easier to answer with PRA and Crystal Ball because you want to look at them in Excel because of all the financial capability. So let's see how this translates. So coming back to it, we pulled up the probabilistic cash flow, and we want to look at what our cash flow will be at 10% and 90%. And it creates a median. So you have the median view over here. I believe that's the median. No, it's the mean, I think it calculated. And then you have the P90. So 90% of the time, the number will be below this line. And 90% of the time, it will be above this line. And the space in between is 80% of all the project occurrences. And you'll notice that a lot of what's going on over here is where you think your project and your NPV will look like in terms of costs. And you'll see that your costs are going up. So you can look at this as a cumulative curve, okay, and you can compare it to the deterministic. And if we were using conventional project management methodologies, it would tell us that this is what our cost curve would look like. But when you simulate it, you realize that it could be actually very different, cost you a lot more, and take you a lot longer than what your deterministic estimate is. Take out that. Then you can see where so if you add more information, so the period bars, so how much effort is being put in and cost, it's there. And just to get a deterministic view off. And then we can look at EVA, so your earned value management, and how that looks over time. And then, of course, we can look at the bar differences, and we can look at annotations. So here and so on. So there are a lot of very impressive and very cool graphing features that enable you to analyze and present the risk relating to your cost expenditures and your cash flow to management, so that with proper cash planning, you can avoid project shortcomings and delays for getting additional approvals, because it's much easier to assign costs and stuff like that up front. So that's the probabilistic cash flow. Some other things so coming back to our presentation, some of the other things that we can do is that we can export this information into Excel and optimize. So I'm just going to take a quick second and show you what that might look like. So why would we do this? Well, we want to figure out what combination of projects would give us the highest NPV. Now, I want to be clear that what I'm suggesting is a way to take what is produced by risk analysis and P6 EPPM, Enterprise Portfolio, Enterprise Project Portfolio Management, so yeah, EPPM, but in addition. So it's more as a complement and a way to extend the analysis that you would go, and not as a replacement. And of course, it will give you which is the riskiest portfolio and which one's the safest and which one gives you the highest return. So very quickly, we're working on a business opportunity where we have data from historical sales, and we want to improve this. And one of the drivers for this project is how much revenue we can achieve, or we're figuring out that we're going to have over these next periods to finance these initiatives. So we do that. And these green cells, without actually going into Crystal Ball, but just to show you what it is, it's this little ribbon add-in over here. We used a tool called Predictor to forecast this. It's a time series forecasting tool. Those inputs show up over here and drive our NPV model, which we have cost of revenue. So we've made assumptions on business facts, such as operating, and these are all for one project. Depreciation expenses, and so on. So all of these things have been plugged in, and if we could send this spreadsheet to other managers and or other subject matter experts, and they could plug in the numbers, either to be pushed back into EPPM or to supply this project. And this model, therefore, then calculates the payback period and the discounted cash flow, as well as the internal rate of return and the terminal value of the internal rate of return for the total project. Then, because we're a very sophisticated organization, we also do real options analysis, and I'm not going to go into the details of this, but these lattices basically enable you to calculate what the expanded NPV, which is a very hot concept in project management, which basically says that the NPV of a project can change because management can make better decisions over the lifetime of the project. And this is a number that we use to make a decision. Because if you were using just traditional NPV, you might not pick these projects. And that's what we call a real option. And all this fits into our project where we have different methodologies for calculating and this is where we want to be, our portfolio model. And we're just assuming that all these other projects or other things we're working on in the business that have come out of our EPPM, and we're simulating them side by side with this specific example that we have over here. And here we might have assumptions about how many people we can assign, with min-maxes around the kinds of resources, and then it will produce, what has the highest return and a bubble chart. And using optimization, because we're not going to run it necessarily right here, it will turn on and turn off both the resources, so how many people, what is the best combination of people, and it will turn on and turn off which projects that you should be working on to see what will give you the highest return. So that's how you would combine using Crystal Ball and Primavera PRA to get a very complete view of both your financial and your project management risk. So just because I think we're short on time, I'm not going to, we can all, if this is ever something anybody wants to discuss in addition to PRA, please feel free to let me know. I'm going to go back to our presentation. So basically, we built, using this approach, we build our portfolio plan, and there you go. So I guess this kind of wraps up my presentation of Primavera risk analysis and a quick overview of Crystal Ball and how it fits in with PRA and EPPM. I hope this was useful, and that if you have any questions, you can always reach us at Technology Partners Limited, and we have a toll-free number as well as a local number, and if you want to reach me, my extension is 101. So I guess I'll hand the presentation back to you, Matt.
Yeah. Thank you so much, Eric, for doing that. You know, it's nice that you actually dived into the tool a little bit, showing people, you know, how it can really, how applying risk to projects can help them. So if people need to reach out to you, right, they can, if they have questions, if they want to have any more questions about Crystal Ball or what you specialize in, is that correct?
Well, the PRA, of course, and how project risk analysis fits into their organization and how they would get the best of it. And then if they want to take that further within the Oracle stack by looking at Crystal Ball, any of those questions are welcome at any time.
Very cool. Great. Well, thank you so much. And I guess this ends the webinar. Thanks, Eric.
My pleasure.